Okay, let's begin our journey into soil phosphorus. This is one of my favorite units. I've studied soil phosphorus and phosphorus chemistry and fertility for practically my entire career. And I just really like the challenges of phosphorus and the movement of phosphorus in soils and uptake in plants and the effects on the environment and trying to figure out ways to offset those effects. That's what I've done partially from my career. So with that said, the learning objectives for Unit 6 are fourfold with sub-objectives underneath the four main. So the first main objective is to simply understand plant and phosphorus relationships. And to understand those relationships, you need to know the forms of phosphorus that are taken up by plants. You should be able to understand the role of mycorrhizae in plant uptake, specifically arbuscular mycorrhizae. Should be able to name the functions of phosphorus in plants. Why is phosphorus important? Why is it a necessary nutrient for plant growth? Next, you should be able to describe plant responses to P fertilization. What happens when a plant is deficient? You add phosphorus. What do you see? And you should be able to identify phosphorus deficiency symptoms. And by this, I mean by visual observation and making note of when you see a P deficiency. Main objective number 2 is you simply need to understand the phosphorus cycle. If you don't understand the phosphorus cycle, you can't understand the relationships that phosphorus undergo in soils to become deficient in the first place. So understanding the phosphorus cycle is critical. And under this objective, you should be able to describe the effect of pH on soil solution phosphorus concentration. Plants obtain phosphorus from the soil solution. So understanding how pH affects that or the availability of phosphorus in the soil is important. You should be able to understand the processes of phosphorus adsorption and desorption, phosphorus dissolution and precipitation, and mineralization and immobilization. Some of these terms sound familiar. Some of them are new. And we'll talk about these in this unit. And you should be able to describe the environmental concerns associated with phosphorus. And some of you likely know if you've lived in the Midwest or if you lived in Ohio for quite a number of years, there's certainly phosphorus issues with Lake Erie, for example. Objective number 3 is to know the pros and cons of the primary commercial and organic P sources. And then objective number 4 is to apply the understanding of the phosphorus cycle to applied questions. Right, so if you're given a question, you should be able to answer it based on your knowledge of the phosphorus cycle. And you should be able to interpret some soil test results and calculate phosphorus fertilizer application rates based on test results. And finally, evaluate the effectiveness of best management practices, or BMPs, for the reduction of P loss. And P loss, by that I mean from soils themselves. So let's take a look at this picture. Right, so we, as humans, we've known the benefits of phosphorus for crop utilization and increases in crop yield for at least 100 years. In fact, the discovery of phosphorus just had its 350th anniversary. So it's been about 351 or 2 years since phosphorus was discovered by humans. And in between then and about 100, maybe a little bit over 100 years ago, we've come to know that phosphorus fertilizers can improve yield. So the picture you see here is a picture of sugar beets from the 1930s. And the sugar beets on the left-hand side did not receive phosphate fertilizer, while the sugar beets on the right-hand side did receive phosphate fertilizer. Now you can see that the yields were dramatically increased with phosphorus fertilizer applications. And there's some really specific reasons as to why this occurs, and specifically with sugar beets that we'll talk about in this unit.